Factor completely. Likely, most people probably would have trouble factoring trinomials with such large coefficients like this one. But by the end of this video, you'll be able to factor any factorable trinomial such as this ridiculous one. Now, before I go over this technique, it is recommended that you have a calculator that can prime factorize, as that is required at a certain step. First, let's go over what a complex trinomial is. A complex trinomial is a trinomial of the form ax squared plus bx plus c. An example of that can be 6x squared plus 5x minus 6 is equal to 0. Now, how can we factor such a trinomial? Essentially, we're looking for two numbers. We are looking for two numbers p and q, right? Looking for two numbers p and q such that p plus q is equal to b, and p times q is equal to a times c. And in this case, we want the two numbers to add to 5, and we want them to multiply to 6 times negative 6, otherwise negative 36. But you notice that if we simply make the c term right here a times c, in this case 6 times negative 6, we can actually end up with a simple trinomial with the exact same p and q values. And so these two values would be the same, the p and q. That is because the b values are the exact same, and the a times c values are the exact same. In this case is 6 times negative 6, which is negative 36, and here in this case is 1 times negative 36, which is still negative 36. Now this is a key part of understanding where the formula comes from. Now, for this simple trinomial, we'll now just call it x squared plus bx plus c is equal to 0, and let's say that there's two factors p and q such that they match all of this right here. That means when we fully factor it, we'll end up with x plus p times x plus q, which is equal to 0. Now in this case, when we solve for x, we get that x is equal to negative p and negative q. But we want the p and q values. So now, from here actually, we can multiply both sides of this equation right here by negative 1, which would give us negative x is equal to p and q. And now that we have p and q in terms of x, let's solve for x using the quadratic formula. Now, let's recite the quadratic formula. It states that for a trinomial of the form ax squared plus bx plus c is equal to 0, x is equal to negative b plus minus square root of b squared minus 4ac all over 2a. Now we can apply that exact formula to this trinomial right here, except you notice that our a is just equal to 1. So for this part right here, this is just going to be 1, and this part is also going to be 1, which means that we can simply just omit the a, which gives us that x is equal to negative b plus minus square root of b squared minus 4c all over 2 for a simple trinomial. Now this quadratic formula is derived from completing the square, and if you're still curious about that, you can check out my video on deriving the quadratic formula. Now, knowing that p and q, we know that p and q is equal to negative x, and we know what x is, so multiplying both sides of this by negative 1 will actually give us p and q. And so we get that negative x is equal to b plus minus square root of b squared minus 4c all over 2, which is also equal to p and q. But we are not done here yet. At this point, this formula does work, but only for simple trinomials. From here, we use the fact that c for the simple trinomial is the same thing as a times c for the complex trinomial. Now, what I mean by that is, you notice that the c value here is negative 36, and for this one, which is we consider the a complex trinomial of equivalent p and q values, the a times c, 6 times negative 6, is equal to this c value, which is negative 36. And it may look a little weird, but we can basically treat this as c is equal to a times c. I know it looks a little weird, but now subbing in c equals a times c, we get that p and q is equal to b plus minus square root of b squared minus 4ac, let me write that better, ac all over 2. And that right there is the factoring formula. Now, let's apply this to the complicated trinomial shown at the start of the video. So here is the question again. 47,053x squared plus 3,840x minus 10,573, and we would like to fully factor this expression. So I also wrote down the formula right here, p and q, the two numbers we want to split the b term into, is equal to b plus minus square root of b squared minus 4ac all over 2. So to apply this to the formula, let's first recognize all our coefficients. Our a is equal to 47053. Our b is equal to 3840. And our c is equal to negative 10,573. And here, now we can just simply plug it into the formula. So our values, p and q, is going to be equal to 3,840 plus minus square root of 3,840 squared minus 4 times 47,053 times negative 10,573. I had to make the square root longer. It's going to be all of this divided by 2. And from this, we get two numbers because there is a plus minus. And it doesn't matter which order you do it in. We'll just say p is our plus version and our q is the minus version. And if you use a calculator, you'll get that p is equal to 24,307. And our q is equal to negative 20,467. Now, with these two numbers, we can rewrite the b term. So now we can rewrite it as 47,053x squared plus 24,307x minus 20,467x minus 10,573. And now, like if we're just factoring a simpler trinomial, we just want to find the greatest common factor between these two numbers and then between these two numbers. And how can we do that? We can do that by finding the prime factors of the coefficients. So for this one right here, if we prime factorize, you'll notice that we get 211 times 223. And for this one right here, we will be getting 109 times 223. And so what this means is that between these two numbers, our greatest common factor is going to be whatever prime factor that matches. In this case, our GCF between these two numbers is going to be equal to 223. Oh, and x, because they both have the x term. X term? No, the x variable. Anyways, now for this one right here, if you prime factorize, you will be getting negative 1, because a negative, times 97 times 211. And for the last one, again, it's a negative 1 times 97 times 109. And so in this case, what are the numbers that match? It's going to be negative 1 and 97, negative 1 and 97. So our greatest common factor is equal to negative 97. Now knowing those, now we can simply just factor by grouping. So for our first two terms right here, we can factor out 223x, which leaves us with 211x plus 109. Now it's going to be this, and we factor out negative 97 for the last two, and then we'll be left with 211x plus 109. And now we have two terms with the greatest common factor, 211x plus 109. So we can factor that out. 211x plus 109, which leaves us with 223x minus 97. And that would be your final answer for this problem.